Now, we're going to talk about satellites. Now, when you talk about satellites, there are a few things that you must know, satellite communication. Number one, when you are transmitting the signal from the station to the satellite, the frequency that you use is called your uplink frequency. The frequency that you use to transmit the information from a satellite back to the ground station is called the downlink frequency. The uplink frequency and the downlink frequency must be different, so you need to know why. Here it says that they are different, so you can actually highlight this point. Number 4 here, you can say that the two carrier frequencies are different to prevent the satellite's high power transmitted signal swamping its reception of the very low power signal that it receives. So what does it mean? Now, the idea is whenever you have the signal that sends up to the satellite, the signal will suffer from attenuation, right? That means the signal power will be lost along the way. So when it reaches the satellite, it's a very weak signal already. So before you can send back to the ground, so let's say this, you're watching the English Premier League. So they broadcast from UK, reach the satellite up there, it's very weak. So they want to send back down to Malaysia, your Astro station. You will need to amplify first. If you don't amplify before you send back, then it's too weak. So how to amplify it? So your satellite here will make use of solar energy, which is free, to amplify the signal. And then they will send back down again. If the uplink and the downlink frequencies are the same, then what will happen is, because there are actually two satellite dishes, one to receive, one to send. If the satellite dish that sends out the signal is using the same frequency as what you are receiving, then the satellite dish that is receiving from the ground will also be able to pick up the signal that you are sending out again, right now. But which power is stronger, the one that came from the ground or the one that you're sending out again? The one that you're sending out again, because you already amplified. So what will happen is this signal will overpower the new signal that you're supposed to receive. So you keep having a loop here. So you get from here, you amplify, you're supposed to send down, but because your receiver is tuned to the same frequency, then it picks up again. So it picks up again, then you amplify, then it picks up again, so what you hear is a positive feedback. You know, sometimes when you put the mic near your speaker, you hear like, ee, very loud like that. So something like that. So you have this positive feedback. Okay, thanks Chong-En for volunteering your voice. Okay, so what will happen if you want to avoid this sudden like sound that Chong-En make? So what you can do is you can actually use different frequency. If you use different frequencies, then the receiver will not pick up this signal anymore, because the signal that you're sending down is using a different frequency than what you're receiving. So therefore, this receiver will not pick up this anymore. So you prevent this high-powered signal from swamping the very low-power signal that it receives. That's what it means. And the typical pairs of frequencies you must memorize. So they gave you certain examples like 6.4 gigahertz, that means uplink 6, downlink 4 gigahertz, or 1411 or 3020. So 14, 11, 30, 20. Do you realize that the uplink frequencies are always bigger than the downlink frequencies? Do you realize that? There's a purpose to it. Remember I told you in the previous video that for EM radiation, the higher the frequency, the higher the attenuation. So because you have to use two different frequencies, you have to choose which one you want to use as the higher frequency, the uplink or the downlink. We would rather the uplink has the higher frequency. That means the uplink will suffer from greater attenuation, because the satellite can make use of free solar energy anyway to amplify. If you choose a lower frequency, means lower attenuation here, then when you send back down, the station will get even weaker signal. And the signal and the station here is not using solar, so you have to use energy to actually amplify it. So you would rather the uplink have more attenuation rather than the downlink. So our uplink frequencies are always bigger than your downlink frequencies. Do you understand? Okay? So please memorize the values. They will give you example 6, so what is the other frequency for? Or they give you 20, what's the other frequency 30. So you must memorize that. Alright, next thing you need to know about satellites is why do we need satellites when your amplitude modulated wave, that means the frequencies of the waves in the lower regions, they behave like surface wave or sky waves, which means they can travel very far. Remember? For example, long wave and medium wave, their range is 1,000 kilometers. Short wave has a range of worldwide. So if they can already travel worldwide or 1,000 kilometers, so why do we still need satellites? So you must remember there are 3 reasons. Number 1, your long distance communication on these wavebands is unreliable. Why? Because number 1, your sky waves rely on the reflection of the waves at the layer of ionosphere right now. So if this is the Earth, this is a layer of ionosphere. So layer of ionosphere is another layer of the atmosphere. Atmosphere have multiple layers. So ionosphere is the charged layer lah. So if the signal sends up here and bounces back, so theoretically we can go worldwide. Okay? But why we don't use them? Why is it considered unreliable? Because this layer of ionosphere is not a fixed height. They actually vary in height and density according to the time of the day. For example, let's say the layer of ionosphere moves up higher, then when the signal you send back to the same point, it will be reflected at a different point. So if you had a station here, initially could receive, now you cannot receive anymore because it bypasses you. So it is not reliable. And surface waves, because it relies on the Earth's magnetic field that causes it to bend a little bit, not so much, maybe they don't draw so much. Let's say this is the station, we can bend a bit. But if you had hilly areas or tall buildings, you will block it off. So they are not reliable. Second reason is that the wavebands are already filled with existing broadcasts. What does it mean? Now, these wavebands, which are the lowest frequency of the radio waves that we are using, which we usually reserve for AM radio, is already used for AM radio. It's not to say you are finding a new range of frequencies that you want to transmit TV broadcast, for example. It's already currently used by AM radio. So it is not empty. If it is empty, then perhaps you can choose to use it. Understand? The third reason is your bandwidths are too narrow. So the lower frequency regions are the one that behaves like surface waves or sky waves. Unfortunately, lower frequencies means you have also lesser bandwidth to work with. So it is not sufficient to transmit, for example, pictures. Or maybe even voice itself. Remember, it was all a muffled one because lower frequency sounds can only fit. Higher frequencies cannot even fit. So because of that, you do not use these surface waves or sky waves as a permanent solution. So we have to use satellites anyway. Satellites will overcome this. You understand not? Okay? So the next one, you need to know the comparison between polar satellites and geostationary satellites. So now, how many types of satellite orbits? Of course, you have many. Examples will be your geostationary satellites that you learned in your gravitational field in your previous chapters. Remember, we talked about geostationary satellites as being orbiting around the equator and having a period of orbit of 24 hours, moving from west to east, so it follows the spin of the Earth right now. So it always remains above the same point on the Earth. So this is one orbit. There's another orbit which is the polar orbit that goes around the poles, in fact. Instead of going around the equator like a geostationary orbit, it goes around the poles. There's another one we also have is the GPS satellites. We also learned that one is an angle one to the axis. So there are many types of orbits, but you need to know the comparison between your geostationary orbit and polar orbits. Geostationary orbits have a radius of 4.23 times 10 to the power 7 meters, it is not, what do you call it, you cannot adjust it, you cannot choose whatever radius you want. Alright, so it's already fixed at 4.23 times 10 to the power of 7 meters. Why? Because of Kepler's third law, which is d squared over r cubed equals to 4 pi squared over gm. So therefore, since the ratio of t squared to r cubed is constant, because 4 pi squared over gm is constant, if you want a period of 24 hours, you must have this radius. You cannot choose. Unfortunately, there are few weaknesses of geostationary satellites which are compensated by the advantages of polar satellites. So always remember, your disadvantages of geostationary will become the advantage of polar satellites. And the advantage of geostationary satellites will become the disadvantage of polar satellites. So one of the problems is because it's so high up, you have a greater delay in communication, right? So geostationary satellites, you will need some time for it to go and come back. This is why when you watch Astro live telecast, there's always a slight delay from what is happening at the source, because it has to go up into the sky and then come back to the station, and then the Astro station will send up again to Miasat, and then Miasat will send to your house. So it's 2 times up. So they use a satellite that maybe doesn't belong to them to bring the information from UK, let's say watching live telecast of the football match, to the Astro station, ground station. From the Astro ground station, after they have edited or censored or whatever, they will send back up to the Miasat satellite, and the Miasat will send back down to your house. So all this will take at least a few seconds delay. So you cannot avoid it because they are already at this fixed height. You cannot adjust. So polar satellites are designed to orbit around the Earth at a much closer distance. Why? Because their period of orbit is only 90 minutes. 90 minutes compared to the period of orbit of geostationary satellites. So if the period is smaller, the radius also smaller. So they are much nearer to the Earth. So that gives us less delay. And if you want to take up close-up pictures of something that's happening on the surface of the Earth, polar satellites gives you a better image because it's nearer. Example, when we went to the Malaysian Meteorological Center, at that time to monitor we want to see how they monitor the haze, because you see they always tell you which part have open burning. So they showed us satellite images from geostationary satellites and polar satellites. So geostationary satellites give you roughly the area that is hot, but polar satellites can actually zoom into the image of the fire burning. So you can actually do that. Okay, so that is the advantage of polar. It pairs up with the disadvantage of geostationary. So geostationary, greater delay in communication. Polar advantage will be less delay in communication. Another disadvantage of geostationary satellite is that it cannot cover the polar regions. If you were to draw the coverage of this geostationary satellite, can you see this? It will miss the polar regions. If you have another one here, it will also miss the polar regions. Alright, if you draw, I can't draw properly here, but you will notice if I draw like this, maybe it is more obvious. Okay, you'll miss the polar regions. So polar regions being here. So polar regions got no coverage. So imagine you are relying on satellites for communication, like maybe satellite phone when you are in North Pole or South Pole doing expedition. You cannot communicate using satellites because it does not cover you if you are using only geostationary. But polar satellites go around the pole, which goes like this. So you actually get to have total global coverage, provided you use a network of satellites because they will keep on moving away one. Okay, they keep on orbiting, but your Earth spinning this way, but the polar satellites move this way. So you need a network of satellites to maintain continuous connection. That means when one satellite moves away, you're going to connect to the next satellite. But they're all connected to each other, so it's not a problem. Okay, so that becomes the second disadvantage of geostationary, which is unable to cover the polar regions. So the polar satellites help to compensate for it. It can cover the entire Earth. You can say total global coverage with a network of satellites. Now, what is the disadvantage of polar? It is the advantage of geostationary. The advantage of geostationary satellites is what we like. It does not need to be tracked by your dish aerial. That means the moment they install for you the astro satellite dish, forever you don't have to touch it anymore. Because it moves together with the Earth's rotation, so it's always pointing in the correct direction. But polar satellites will move across the sky. Because as your satellite orbits this way, the Earth is spinning, so they'll move away from your horizon. So you continuously have to track it until it goes out of the horizon, then you have to track the next satellite. So if you are using a polar satellite, your dish area must be able to move on. Must be able to rotate on. So you keep on tracking the movement. So they also showed us how they track the polar satellites. They showed us, right? They showed, okay, right now we are tracking this satellite. In how many minutes this satellite will go out of the line of sight. So we have to take another satellite that's coming in. So the next satellite is coming at what time, so we will switch over. So this is what they do lah. This is polar satellite. So always remember they complement each other.